Alright, nung nakaraan, dinefine natin kung ano ang rings, nagbigay tayo ng maraming examples, dinefine natin kailan ang ring, commutative ring, ano yung sabihin ng unity ng ring. Nakita natin na hindi lahat ng rings ay commutative at hindi rin lahat ay may unity. So, to proceed, pag-aaralan natin ngayon sa video na ito ang mga basic properties ng ring. Ito yung sabihin ng mga properties na totoo sa lahat ng rings. Okay. In a ring R with operations plus and times, these properties hold. Number 1. It meant to say that any element when multiplied to 0 gives you 0. So, natural, no? Kasi yung mga real numbers even ay may ganyang properties. Kahit anong number yung multiply mo sa 0, nalabas ay 0. It is a property actually that is true for any kind of ring. Lahat naman kasi ng ring may 0. So, any element multiplied to 0 will give you 0. We shall prove that in a short while. On the number 2, a times the inverse of b under addition is equal to the inverse of a times b, and that these products are equal to the inverse of the product AB. So, parang familiar ito. No? So, these are basic algebraic properties na alam nyo na noon. But, this time, dapat aware kayo sa pinagkaiba-iba ng tatlong ito. Although, automatic sa isip nyo sa basic na algebra na sila ay pare-parehas, but they are not really the same. I mean, the meanings are not the same. Nagkataon lang that their values are equal. So, gaya na ito, minus A times minus B is the product, same as the product A and B. Now, in a ring, take note of this notation. Nakikita nyo ba? Yeah. Kapag sinulat natin A minus B, ang ibig sabihin talaga natin nun, tatakpan. Pag sinulat natin 8 minus B, ang ibig sabihin talaga natin nun, A plus the additive inverse of B. Alright? Okay. So, dapat yung A times B minus C mag-equal din sa AB minus AC. Parang distributive property lang ito, pero instead of addition and nandun sa gitna, subtraction. Tawagin natin subtraction. Okay? Yung last property ay nag-hold, syempre, kapag may unity yung R. Kasi, hindi naman lahat ng ring may unity. Right? So, dapat yung additive inverse ng unity times A must equal to minus A, must be equal to minus A. Same with A times minus 1. So, for the proof, bakit nga ba ang A times 0 ay 0? Well, kasi ang A times 0 can be written as A times 0 plus 0. Dahil yung 0 ay additive identity. Now, by the distributive property, you can write this as A times 0 plus A times 0. Question is, why would this imply that A times 0 is 0? Because the ring is a group under addition. So by cancellation law, meron kasing cancellation law ang groups, di ba? Ito yung maglagay ng 0 dyan, tapos naglagay ka ng 0 dito, cancelin mo to, ang may iwanan ito. That's why ang A times 0 ay 0. Now, I will let you do the other direction. Similar lang naman ang proof niyan. Alright. For the next property, when you look at A times minus B, and then, gusto mo ipakita na siya ay negative ng A times B, that is the same as proving that the sum of these two, ito, tsaka yung nasa loob, dapat 0. So, kapag inad natin sila, distributive property, pwede mong ilabas yung A or i-factor yung A palabas. Now, what is minus B plus B? That is 0. Now, A times 0, according to the previous property, is 0. So, pag inad mo itong dalawa, ang lalabas ay 0. Sabihin, ito yung negative ng AB. You get that? Na yung other equality, I will let you do that as an exercise. Ito yung exercise. Okay? The third property. Yung third property ay consequence ng number 2. Paano? Well, kasi yung minus A, yung minus A times minus B, kung i-apply natin muna ito, yung equality nito, yung minus na ito lalabas. Right? Tapos dito sa loob, i-apply mo naman yung pangalawa. Yung una. Yung minus ng B, lalabas sa unahan. Now, ano yung inverse ng AB? Well, in any group, that's the same as AB. That's it. Yung number 4 naman ay in-apply lang yung notation na ito, tapos yung distributive property. Makikita nyo sa screen. Nakikita nyo ba? Okay. Kayo na bahala magbasa. Yung number 5 naman, dahil yan dito, minus 1 times A, by property number 2, once again, lalabas yung minus sign, is minus of 1 times A. But what is 1 times A? 1 is the identity for multiplication, so 1 times A is A. Kaya ito yung minus A. And in a similar fashion, yung A times minus 1 is minus A. Okay? Now, there are more examples right here. So, here, si R ay ring, si A ay ring element. So, for example, ang laman ng R, mga matrices. Imagine mo kunwari matrix si A. Pero yung N dito ay isang positive integer or isang natural number. Pag pinagdikit natin sa ring theory, yung N, A, for example, sa concrete example, 2A, no? Does it mean 2 times A? No, kasi hindi mo naman po pwedeng i-multiply yung 2 sa A kasi maaring halimbawa si A ay matrix, si 2 ay number, so hindi sila compatible. Anong meaning natin ng 2 times A talaga? Meaning talaga nun ay A plus A. But A plus A, i-add mo si A sa sarili niya ng dalawang beses. So, parang si N ay counter kung ilang beses ka mag-a-add. Similarly, kapag naman repeated multiplication, ilalagay natin yan sa taas. Ang tawag natin exponent, di ba? Okay, so ang A squared, meaning nun, A times A. Ano naman ang minus N times A? Halimbawa, negative 2A. Ano yung sabihin yan, sir? Ang yung sabihin lang yan, yung minus A, uulitin mo ng dalawang beses. Okay? Okay. Example, pag meron kang 3A squared minus 3B, ano yung sabihin yan? Yung sabihin yan, tatlong A squared i-add mo, tapos mag-a-add ka ng tatlong additive inverse ng B. Kaya nga, pag in-expand mo siya, ito talagang meaning yan. Ito yung 3A squared, at ito yung minus 3B. O, diba? Parang algebra. Oh, as an example, as a concrete example, let's consider the ring R of 2 by 2 real matrices. Let's consider the matrix A na ang laman ng entries ay 1, 1, 0, 1 as shown. So, let's calculate the expression A squared plus 2A, for example, ang meaning niyan. So, again, ang A squared plus 2A, ang meaning talaga nun, A times A plus A. Okay? So, pag sinulat natin yan in matrix form, ganyan. Diba? Now, paano ginagawa yung multiplication? Marunong po ba kayo? Ganito yun. Dot ng mga rows by columns. Ito yung A na isa, ito yung A na isa. Idadot mo itong dalawa, you'll get that. 1 times 1 plus 1 times 0 is 1. Next, ito, idadot mo itong dalawa to get this. 1 times 1 plus 1 times 1 is 2. And so on. Kaya nga ang sagot, yan, 1, 2, 0, 1 plus. Okay? Alam naman natin na ang addition ay associative, so no need to put parenthesis. A pair of parenthesis. Pag inad mo yan, palabas, 3, 4, 0, 3. So, yun yung meaning ng a squared plus 2a. Nakita nyo yung a ay matrix, yung coefficient na 2, tsaka exponent na 2 ay mga positive integers. Now, this is what we call as the binomial theorem. So, may binomial theorem tayo ng pambatang algebra. Yes, that even holds in an arbitrary commutative ring. This is very important kasi yung theorem na to hindi nag-hold kapag ang multiplication ay hindi commutative. So for example, in the ring of matrices, hindi nag-hold ang binomial theorem. Wag na wag niyang i-apply. So for example, pag si A and B kunwari, matrices, no? Sulatan natin. Para sa A and B, mga 2 by 2 na matrices, for example, wag mong i-expect ng A plus B squared ay parehas sa A squared plus 2AB plus B squared kasi ito nanggaling sa binomial theorem. This is not necessarily true for 2 by 2 matrices A and B. So, madali lang gumawa ng counter example, diba? Although there are cases where these two are equal, I want to emphasize that. Nangyari yun when A and B commute with each other, di ba? Napag-aralan natin sa linear algebra. Now here, yung n ay exponent, yung symbol na to ay coefficient. This is a positive integer. Ito rin positive integer. Ang ibig sabihin ng n taken k, ang basa natin dyan, n taken k. Ito yung n factorial divided by n minus k factorial times k factorial. Ito pa rin yung standard na binomial theorem. Yung mga coefficients na yan, yan yung nandun sa Pascal's triangle na alala nyo, if you could remember. Now, bakit hindi ko na ito ipoprove? Kasi yung proof na ito, almost the same yung proof dun sa real number na case. You can prove this several ways. For example, you can use mathematical induction or you can prove it combinatorially. Maraming iba't ibang proof na ito. So, as a reading assignment, you can Google the different types of proof of the binomial theorem para tong Pythagorean theorem, but gasgas na rin. Kasi maraming iba't ibang proof. As an illustration, in the ring z sub 3, okay, nasa z sub 3 tayo. A plus B cube, anong sabihin nun? A plus B, makita nyo magkaiba yan. So ito, ang meaning talaga niyan, A plus B times A plus B times A plus B 3 times. Pero ito, meaning niyan, A, ito ang meaning niyan, A squared B, AAB plus AAB plus AAB plus tatlong 3AB squared. ABB plus ABB plus ABB plus BBB. So, yan ang meaning talaga niyan. Now, kaya lang, ang mga elements ng Z sub 3 may property. Pag inad mo sila sa sarili nila ng tatlong beses, ano lalabas? Diba? 1 plus 1 plus 1. Sa Z sub 3, that is 0. Kaya yung mga terms na ito, they will be zeroed out in Z sub 3. Kaya maiiwanan lang a cube plus b cube. Weird, no? Kasi nung mga bata kayo, pinagbabawal ito. Pero sa Z sub 3, it even holds. In fact, nag-hold yan sa lahat ng Z sub p where p is prime. Okay? Alright, let's now talk about fields. Again, i-recall natin. Hindi required ang multiplication ay commutative, pero kung commutative man, what do you call this? Commutative ring ang tawag. Hindi rin required na ang multiplication ay may identity, pero hindi pinagbabawal. Kung meron man, ang tawag doon ay unity. Now, kung let's say, ring mo ay may unity, ang kasunod nun, tatanungin mo kung yung mga elements ay may inverse under the multiplication. Kasi may identity ka na eh. Ang kasunod nun ay inverse. So let's look at this definition. Let R be a ring with unity 1. A non-zero element U of R, non-zero si U, is a unit if it has a multiplicative inverse. So, lahat ng mga elements na may multiplicative inverse sa ring ay tinatawag nating unit. Pero by default, ang 0 ay hindi unit. Kasi by definition. Kasi parang sa sense ng real numbers, para mong i-allow na mag-divide by 0, which is of course not allowed. Okay? Ibig sabihin ng multiplicative inverse is just an element symbolized by u to the minus 1. So that when u to the minus 1 gets multiplied to u, ang sagot ay yung unity na 1. Okay? Now, ito na. Kung lahat ng non-zero element, halimbawa, tingnan nyo yung set of real numbers. Diba lahat ng non-zero element may kanya-kanyang mga multiplicative inverse? Kapag nangyayari yun, lahat ng non-zero element ay may multiplicative inverse o yung mga unit sila. Ang tawag sa ring na yun ay division ring. Ba't kaya tinawag na division ring? Kasi kapag ang ring ay division ring, division is now possible. Pwede kang mag-divide. Even more, kung division ring mo ay isang commutative ring, yung multiplication commutative pa, ang tawag namin dyan ay field. Okay? So, to summarize, may na-observe ba kayo? If R is a field, kapag ni-remove mo yung 0 from the set, sorry, this is wrong. There's a typo. Pag ni-remove mo yung 0 doon sa set, yung ring mo without the 0, bubuo ng abelian group under the multiplication. So, hindi lang siya group under addition, yung mga non-zero elements pa niya ay bumubuo ng group under the multiplication. Naintindihan nyo ba? Non-zero, hindi kasama yung 0. More generally, if R is a ring with unity 1, if you collect all the units of R, yung mga may inverse, they form a group under multiplication. Sa case ng unang remark, yung lahat kasi na non-zero, di ba? Now, hindi kasi lahat ng rings ay division ring. Makikita niyo sa mga examples. Pag kinolect mo lang yung mga may inverse, sila lang yung bubuo ng group under the multiplication. And by default, unity na 1 ay unit. Kasi ang 1 times 1 ay 1. So, ang inverse na yung sarili niya. Okay. So, as examples, the rings Q, R, and C are fields. Kasi, halimbawa yung mga rational numbers, lahat ng non-zero elements niyan may multiplicative inverse. Ang tawag na natin ay reciprocal. Diba? Ang reciprocal din ng mga real numbers ay mga real numbers pa rin. Sorry, non-zero. At ang reciprocal ng mga non-zero complex numbers ay complex number pa rin. Pero, tingnan nyo. Kanina yung Z ay commutative ring with unity, but it is not a field. Kasi when you try to observe kung sino-sino yung mga units doon sa Z, sino-sino nga ba? Sino yung mga may multiplicative inverse? Ano ba si 2? Kasi si 2, ang inverse niya, dapat 1/2, diba? Kaya lang mo 1/2, hindi naman siya integer. Required na yung inverse nandun pa rin sa same na set. Did you get what I mean to say? So 2 is not a unit. 3 even is not a unit. Not even -2, -3, 4. So what are the units? Yes, of course, 1. Because by default, 1 is a unit. Aside from 1, what else are your units? Sige nga. 1 and -1 only. Dahil hindi lahat ng non-zero ay unit, it cannot be a division ring. Kahit na siya ay commutative ring with unity. So it cannot be a field. Hindihan nyo. The ring Z sub 5 has addition and multiplication tables as shown below. So ginawa ko na sa inyo, para sa inyo, yung Cayley tables for addition and multiplication ng Z sub 5. Ang tanong, si Z sub 5 ba ay field? Well, walang duda na group siya under addition. Ngayon, ano yung tanong natin? Commutative naman yung multiplication, right? May unity rin yan, ang unity ay 1. Tanggalin natin ngayon yung 0 kasi hindi kasama ang 0 sa usapan pag-usapan ng units, diba? So, remove the 0 from this table. May iwanan ka nito. Ang tanong, yung naiwan ba, do they form a group under multiplication? Well, let's see. Notice that 1 times 1 is 1, right? 2 times 3 is 1. Of course, 3 times 2 is 1 as well. And 4 times 4 is 1. So, each one of 1, 2, 3, and 4 has an inverse. In fact, the inverse of 1 is 1, the inverse of 2 is 3, the inverse of 3 is 2, and the inverse of 4 is itself. Therefore, the units of Z sub 5 are 1, 2, 3, and 4 kasi may mga inverses sila under multiplication. And these are precisely the non-zero elements of Z sub 5. Therefore, this is a division ring. Since Z sub 5 is a commutative ring, Z sub 5 is a field. Do you get that? Oh, may tanong ako. Is Z sub 4 a field? Sagot dyan, no. Lagi naman ganyan ako, di ba? Kapag yes, ang susunod na tanong, ang sagot, no. Note that, sorry, may typo na naman yata. Ang 2 times 0 ay 0. Ang 2 times 1 ay 2. Ang 2 times 2 ay 4, pero modulo 4, that's 0. Ang 2 times 3 ay 2. Ang product ba ng 2 with any ay naging 1? Ever? Naging 1 ba? 2 times 0, 0, 2 times 1, 2, 2 times itself, 0, 2 times 3 is 2. Naging 1? Never, di ba? So, ibig sabihin si 2 ay walang multiplicative inverse. Kaya nga, 2 inverse does not exist, therefore Z sub 4 is not a field. In fact, 1 and 3 are yan. Are units in Z sub 4. And ang inverse ng 1 ay 1 kasi ang 1 times 1 ay 1. Ang inverse ng 3 ay sarili niya rin kasi ang 3 times 3 ay 9 modulo 4, it's a 1. In fact, when you construct a table for 1 and 3 only, so ang units ng Z sub 4 to follow up, ano naman 1 and 3 lang. If you construct a multiplication table, ito 1 times 1 is 1, 1 times 3 is 3, 3 times 1 is 3, 3 times 3 is 1. You see that this is a group which is isomorphic to Z sub 2. Do you remember that? Ang Z sub 2 under addition, ito diba? Isomorphic sila. So, meron tayong general na question. When is Z sub n a field? Kasi hindi lahat ng Z sub 5 field, pero ang Z sub 4 hindi. Kailan nga ba nagiging field ang Z sub n? So later, we shall have an answer for that. In fact, the answer is when n is what? A prime number. 5 is prime, 4 is not prime. This is a linear algebra stuff. So, ano yung mga units ng mga 2x2 real matrices? Ang tawag natin sa kanila sa linear algebra ay mga non-singular matrices. In fact, na-identify natin sila. Alam natin na infinite yung mga yan, na marami sila. And we were able to formulate several equivalent conditions for being non-singular. One of those, dapat yung determinant ay hindi 0. Ano pa ba iba? Dapat ang RREF ay identity. Dapat yung linear transformation associated to non-singular matrices ay mga isomorphisms. Diba? Yung mga yan. So, dapat yung kernel ay trivial, yung range ay spanning, etc. How about the ring of integer polynomials? Is that a field? Well, the answer is what? No, kasi halimbawa yung x. X is an element of z square bracket x. Do we get a polynomial na multiply mo kay x para ang sagot ay 1? Well, dapat ang sagot 1 over x. But, 1 over x is not really a polynomial. Okay, nasa dulong bahagi na tayo ng lesson 1. Direct sum. So, kapag meron kang dalawang rings, pwede mo silang pagsamahin in a certain fashion so that the resulting set is again a ring. Pero yung paraan natin ng pagsasama ng dalawang rings dito ay hindi parehas ng union, hindi rin intersection. Ang tawag dito ay direct sum. Paano ginagawa yung direct sum? Kukunin mo lahat ng mga ordered pairs, R and S, so that R is in R and S is in big S. Take note that R and S possibly have different additions and multiplications. Okay? So, ang laman ng R plus S, tawagin natin plus S, or direct sum ng R and S, ay mga ordered pairs. Parang, kung halimbawa, si R, yung real number line, pag naman direct sum na ito, sa linear algebra, alam nyo na yun, yung R2, ito yung Cartesian plane. Ito yung line. Okay? So, paano yung addition dito sa direct sum? Pag nag-add ka ng dalawang pairs, i-add mo lang sila component-wise. Yan. Pag nag-multiply ka, component-wise din. Ang tawag yung component-wise addition at component-wise multiplication. Ang 0 ng ring na ito pala, sorry, nakalimutan ko, ang 0 niyan, syempre, ay 0, 0. Pero take note, itong unang 0 ay 0 ng R, yung pangalawang 0 ay 0 ng S. Kasi halimbawa, pwedeng si R ang laman mga real numbers, si S ang laman mga matrices. So yung pair mo medyo weird, no? Yung unang coordinate number, pero yung pangalawang coordinate matrix. So ang 0 nun, 0 na number, comma, tapos 0 matrix. Generally, pwede mo i-extend, alam niya naman sa math, diba? Pag nagsimula ka sa dalawa, titignan mo sa tatlo, sa apat, and so if you have n different rings, no, not necessarily different, if you have n rings, R1 up to Rn, you can take the direct sum of these. Yung nga lang, ang laman na niyan, hindi na ordered pair. Ordered n tuples or mga vectors. Pwede mo isipin vectors. Ang operation ay component-wise addition, tapat-tapat, at component-wise multiplication, tapat-tapat din. At ang zero niyan ay yung vector na ang laman, lahat ay 0. Okay, let's look at some example. Consider the ring R, which is the direct sum of the rings z sub 4 and z sub 2. So, list down the elements of R. Pangalawa, calculate the sum as shown or the expression as shown. So, Cartesian product lang naman yung number 1, diba? So, ang z sub 4, ang laman, 0, 1, 2, 3. The other hand, ang z sub 2 ang laman, 0 and 1. Paano ginagawa ang Cartesian product? Ito, 0, 0, 1, 0, 2, 0, 3, 0, 0, 1, 1, 1, 2, 1, 3, 1. Naalala nyo? So, ayan yung nilista ko dito. So, may sagot ka na sa number 1. How about number 2? Well, ang ibig sabihin ng mga brackets, uunahin mo yung multiplication na yun. Kaya, ganito, 2 times 3, saan mo multiply yung dalawa? Siyempre sa z sub 4. 2 times 3 ay 6, pero modulo 4, the answer is 2. 1 times 1, 4 is 1, yung z sub 2. Sorry. Next, ito naman, 2 times 1, as if you're doing them in z sub 4. Yung 2 times 1 in z sub 4 is 2. Ang 1 times 0 in z sub 2 is 0. So, ito yung product nito. Okay? Pag inat mo naman itong dalawa, 2 plus 2 in z sub 4 is 0. 1 plus 0 in z sub 2 is 1. So, the final answer is 0, 1. Now, kung mapapansin nyo, may common factor ka. 2, 1, tsaka 2, 1. Common factor yan. So, you can use distributive property or yung tawag natin factoring the paano ba yan? Sa algebra ng pambata. Fina-factor out mo yung common na factor. Ayan, ganyan. Lumabas yung 2, 1, naiwanan to. So, instead of multiplying yung dalawa, i-add mo na lang to. Ito yung sum. Kasi yung resulta, multiply mo, sagot ay 0, 1. You get that? Okay, nasa last slide na tayo. Ano ba yung last slide? Yung last slide ay exercises. So, paki-take note ng mga exercises. Actually, wala naman deadline ito, but these are some of the problems that you can start working on. Okay, you may try them at home. If you have questions, you may send me an email, or you can PM me, or in any way. Okay? I hope that you have learned something in this lesson. So yun lang. See you in lesson 1.2. Tapos na tayo sa 1.1. No. Still 1.1 pa rin tayo. Ang susunod na lesson natin ay tungkol sa mga integral domains. Ito yung mga rings that are, yung mga elements ay integer-like. Kaya ang tawag natin ay integral domain. Okay? See you in the next video.